You're all very welcome to this Engineers Ireland webinar event, the Energy, Environment, Climate Action Division. My name is Barry McMullen. I'm the current chair of the division. It's my pleasure tonight to welcome Conall Boland. Conall is a senior consultant in the RPS Sustainability Team, working on climate action, the circular economy and biodiversity for clients across public and private sectors. He lectures in Sustainable Development and Planning and TUD, and sits on the Advocacy Committee of Engineers Ireland. He's a chartered engineer and planner. He's been a board member and deputy chairperson of An Bord Pleanála from 2007 to 2018. He recently appointed to the Centre Steering Committee for Construction Innovate, Ireland's National Research Centre for Construction Technology and Innovation. And Conall is talking to us tonight on the subject of embodied carbon reduction for buildings and infrastructure. I gave a few minutes speech about how important that was. I'm going to skip over that this time and let Colm explain for himself why this is a very important topic. Conall.
Thanks for that lovely introduction, Barry, and welcome everyone online and in the hall here tonight. St. Bridget's Cross, probably the lowest embodied carbon decoration you can get for your house, all naturally grown, and when you finish with it, it'll decay and release this carbon back into the environment, into the soil. So my job is to get you through this talk tonight and keep you away from home and away on the television. Just need to get nudging forward here. So we'll just look at an overview of embodied carbon and maybe explain, or for anyone who isn't familiar with it already, look at some of the projects and how we're going about measuring embodied carbon in those. See how the construction sector is responding overall. Look at the regulatory landscape and what's coming down the track there for organizations and for projects, and then maybe how do we rise to the challenge as an engineering body ourselves. So the first thing to do, we talk about carbon is becoming a very, very common word in parlance and media, but do we understand what it means and do we know what it looks like? And the picture on the right is a slide from an American university in 2013. They said, well, let's create a graphic depiction of what a ton of carbon dioxide looks like, and that's what it is. So we all need to start figuring out more what a kilogram is, what a ton is, what impacts our own lifestyle are having, and more importantly, as designers and engineers and project managers, what impact our projects are having. Now, because you're all good, well knowledgeable CPD people here, you probably know the answer to this off the top of your head. And the answer, of course, is that when you divide Ireland's emissions by the population, you get about 12 tons of carbon dioxide per person per annum. And that's 12 of those big balls that we're dragging around with ourselves individually. If you look at the graphic on the right, you won't be able to see the detail, but it shows from the developing world, the Democratic Republic of the Congo is the country with the lowest per capita footprint, all the way up to Qatar, which is the highest. The average across the globe is about 5 tons. So Ireland is already, double global average per capita. And we're a lot higher than some of our peer countries, such as the UK or some of the Scandinavian countries. And I suppose one of the challenges globally is all the countries who want to develop, who want new infrastructure, who want better quality of life, they have a lot of investment and infrastructure to build. Do they repeat the mistakes we've made with high intensity, high carbon solutions, or can globally we find better solutions and spread them across the world? So the built environment, which is what we're talking about mainly tonight, is responsible for a lot of the global emissions of greenhouse gases. So it's estimated about 40% of all emissions are related directly or indirectly to the built environment, buildings and infrastructure. Also responsible for 40% of energy consumption, 50% of all raw material extraction, so that's a really big footprint on the planet, a third of all potable water use, and a third of all waste generation. So architects, engineers, quantity surveyors, we all have a responsibility to address this. And then in the carbon emissions, about 28% associated with operations, which is the energy and heating generally, and cooling, and then 11% associated with the embodied carbon. So one of the things your committee is working on is reducing the carbon footprint or the carbon content in our electricity grid and our gas grids. And we know we're on a trajectory in Ireland to get 80% renewable electricity onto our grid, which will mean we'll have a very low carbon intrinsic to every unit of electricity we spend by 2030. So that's happening around the world, and as that's happening, the operational carbon is reducing, as seen there in the grey. So the grey elements are getting smaller, but if the green stays the same, the green changes over the coming decade from being a subsidiary element to being the main element in the carbon footprint of buildings. So the graphic is just trying to represent that embodied carbon is going to become a major focus. And I suppose the good starting point then, and keeping the momentum up, is just what do we understand? Have we got a common understanding of what embodied carbon is? Some of us know a little bit, know a bit more. And one of the things we're trying to do is get everyone on the same page on this. So this is a very good document if you want to get into this. It's a relatively easy to understand guide developed by the World Green Building Council, bringing embodied carbon up front. And the diagram on the right really encapsulates the whole thing. So you have three phases for the construction of a building or a piece of infrastructure. You have the upfront carbon, which brings you to the opening of the building. You have the use stage embodied carbon. So that's not heating the building, but it's if you have to replace a window after 30 years, if you have to maintain floors, if you've got to fix cracks or do other operational, let's say operational investment. So that's the embodied carbon during the use stage. And then finally, for anything we build, we've got to think about what about the end of life, the deconstruction, the transport away, and the waste and the emissions associated with that. When you bring all three elements together, that's your total embodied carbon. And sometimes it's referred to as your whole life embodied carbon. So that's what we're drilling down into tonight. And just to give it a bit more of a graphic presentation, the first stage is, we say embodied carbon from the cradle to the grave of a building or a piece of infrastructure. The cradle, you can imagine as the earth or the ground. Everything we build, it starts as either minerals, whether it's metals, cement, aggregates for concrete, all that mining effort, the transport of ore, the transport of materials to places like refineries, cement kilns, steel refineries, oil refineries, all of that is going into making the product. And those three stages are known as the A1 to A3 stages. And that's when you get your building material or product. And that's typically the biggest element of a carbon footprint of any project. It's the biggest element of the embodied carbon. When you have your material, you then transport it. Sometimes it's only from Tallaght into the city centre, maybe a load of concrete. Sometimes it's halfway around the world. You might be bringing a pump in from China or from India. That transport effort has to be accounted for. And then on the right-hand side, if you're developing a building, there's the construction stage effort. There's the compressors, there's the cranes, there's the piling rigs. There's also the waste going off site. So all of that effort and energy can be calculated, and that's called your construction stage, the A5 stage. Then going on to the maintenance and refurbishment. Hard to get good pictures of this. That's replacement of a humble carpet. That's all part of it. Was that after 10, 15, 20 years? Do your windows last 30 years? Does your fencing last 50 years? So all of that has to be estimated and built into your calculation of whole life embodied carbon. And that's very often not as obvious as the construction stage. And then finally, your end of life. So you see a building there is a maybe 30, 40-year-old office block being crunched. It'll be taken off site. There's emissions associated with all that effort to transport, but also end of life. Are there emissions if you landfill that or if you have to treat it in a recycling plant or an incinerator or something else? So all of that has to be accounted for. When you bring it all together, the good news is that there's a standardized reporting system and we're following international norms. All carbon is reported in tons or kilograms of CO2 equivalent. So that's a way of looking at all the emissions across different greenhouse gases and distilling them down to tons of carbon dioxide equivalent. But by using this standardized methodology, and this is taken from PAS 2080, which is a standard for infrastructure carbon, we have carbon classified according to the use stage, whether it's A, upfront, B, operational, or C, end of life. And if we follow this systematically, what it means is we can compare buildings according to what category we're talking about. We can compare projects, and we can also combine the scores from different construction projects. If you're a company that has 10 or a dozen different projects, you can combine your information and look across what phases are causing the footprint. So this is very good. It's harmonized across all the standards dealing with carbon. And that's a good news story that we all tap into this same structure. So when you apply that structure then, and this is one we've done on a building, on a landfill remediation project in County Kildare, when you assess the footprint in embodied carbon, you drill down into each of those categories and you get an output something like this. So in this project, over 50% in blue was the products. So that's actually the plastic liners, the concrete curbs, the lamp posts, the fence material, all the materials account for about 55% of the footprint here. The next biggest category was actually the end of life. When that's decommissioned, maybe 100 years time, how is that disposed of and what's the footprint of that? And then in between you had transport, you had construction processes, you had the replacement and refurbishment, in this case I think over 100 years, and then you had other forms of inputs from waste and so on during the operational lifetime of the project. So the other outputs you can get, then you can examine this according to what materials are giving me the biggest input. And in this case, in Curtistown landfill, it was the plastic membranes, followed by asphalt and the sanding gravel, and followed by plastic pipes and flooring. So on any project, the dimensions of this will change, but straight away you've got a very good picture by drilling into it. Where do I need to focus my attention if I want to reduce this? And you might look at this and say, in this project, are the plastic membranes the area that we really need to focus our attention? Do we replace them with another type of material, or can we change the specification and reduce the footprint? So, and that's what that project looked like. And it's maybe a little case study to pause on. In this case, this was a former landfill site that was quite problematic that Kildare County Council had to take over on behalf of the state and go through. It's been developed at the moment, finalized as a new public park and recreational area. So one of the innovations we did on this project was to do a whole life carbon assessment at the detailed design stage. So we did a life cycle assessment, which I just showed you the results of. Moving on from that, at the tendering stage, we required the tendering contracts to do their own carbon life cycle assessment and to submit a carbon reduction plan, so that they were being compared not just on price and quality and safety, but also on environmental performance. And now we're at the construction stage coming to an end. There's been monthly carbon reporting and updates, comparing it against the benchmark they set during tendering. And that'll be a very interesting output to see what further innovations they brought during construction and how their estimates pre-construction match what was done post-construction. So in this case, it was Kildare County Council and ourselves, and very much the ambition and the appetite from Kildare County Council to push ahead and do something more innovative and to try and make a difference on the carbon front. So just in general, looking at how the construction sector is responding to the challenge of embodied carbon. If there's one key takeaway from the slide tonight, from the lecture, this is the one you want to try and remember. And it really encapsulates the philosophy for thinking about embodied carbon and how to reduce it. Key message is thinking early and starting early about embodied carbon reduction has the most opportunity to reduce the footprint. So it's not a natural question we sometimes ask ourselves as engineers, but the first question you should ask is there a way to avoid this project, or can we build nothing? Building nothing is a surefire way of not having any emissions. So at a very high level, strategic for any organization, are we doing more than we need to? Is this properly sized? Is there elements of this that don't actually need to be built now that we may not need in the future? So that challenging that concept is very important. Moving on from that, if you think about building less, you're moving into the design stage. You can think about building less, or maybe building more efficiently, or building more cleverly. So you're moving into a stage design. You still make the choices here that determine not just the construction stage, but the lifetime stage. When you go into construction, a lot of the die is cast in terms of what type of material, what form, what scale. But there still is lots of efficiency and carbon reduction in how efficiently you build. That can be down to operational methods, whether it's offsite or on-site, whether you use low carbon fuels, et cetera, et cetera. When you get into the operation and maintenance stage, you have less opportunity to optimize and reduce carbon. So the message is think about it early and think about designs that avoid and minimize at the outset, and then move down through the stages. And just to give you an example maybe of this one would be back up in the lean and build cleverly approach. In this project in Glasgow, the Glasgow Airport Investment Area, we were in a design build partnership with Wills Brothers. And one of the parts of the project was to build a road over some buried 138 kV cables, 132 kV high tension cables. So they're oil filled cables. The baseline design was to build a concrete bridge over them. Wills Brothers and ourselves said, well, look, is there a better way? Is there a lower cost way? Could it be done with styrofoam blocks, which they have a lot of experience with? But the regulator, Scottish Power Energy Networks, wasn't comfortable with that in terms of temperature control. We went back to the drawing board and came up with a solution that was using crates used for water storage for sustainable urban drainage systems. So went back, redid the calculations, re-examined the technical and safety aspects, put that back to Scottish Power Energy Networks. And, you know, after some consideration, they gave it the green light. This was built, the saving was a massive 87% reduction on the concrete baseline approach. And that saved 1,300 tonnes of carbon. It probably also saved cost on the project and was fine in terms of programs. So that was recognised with an award in the ICE Carbon Champion Awards in 2021. So going back to that is probably an example of building clever. And I think we all have an obligation now to start looking for solutions like that, and maybe not just repeating the business as usual, pushing the limit. And what was really important here was that Scottish Power Energy Networks were open to the idea of innovation and change, and that's important that the regulators come on this journey with us as well. So in terms of the engineering sector and the civil engineering in particular, how will we find carbon reductions in buildings and infrastructure? And I suppose this is a schema we've developed to a way to think about where we start and where we move to. The first thing I'm calling level 0 is to understand what we're dealing with. And then you move through level 1, which I think is the low hanging fruit, where we don't necessarily revolutionize what we do. We just adapt and optimize existing systems. We need to move on then to level 2, which would be really reassessing the designs, the materials, and pushing further on innovation. And then ultimately, we're going to have to strive for net zero 2050. Pretty much all the economies have signed up to being fully carbon neutral at that stage. So that's going to push us even further in the years ahead. So what I mean by level 0, it's first of all is what is the baseline, and preparing a baseline carbon life cycle assessment. It's becoming the norm for infrastructure projects, but at the same time, it's not done across the board. There's an awful lot of catching up to be done. It's increasingly going to be a requirement for project approvals. So if you put a motorway, a bridge, a transport project, a big water project before on board Conall, they're going to be looking for your carbon accounting. They're going to be looking for a very detailed climate mitigation chapter in your environmental impact assessment report. And the foundation stone for that is to know what the footprint is of the project and to know what the operational emissions will be as well. The overarching standard for this is publicly available standard 2080, and that's 2016, but it's been revised at the moment. So that sets the standard. So your level 0 really is to understand the footprint, identify where the carbon hotspots are, like I showed you in Curtistown, carry out some benchmarking. Is there another kilometre of road you compare with? Compare your bridge deck intensity per square metre, or maybe your water pipeline. How do we compare with international benchmarks? And finally, then you set about, okay, drilling down into your design and your specifications and seeing where can I reduce the footprint. One of the important inputs into that process of understanding your footprint and looking for reductions is quantifying. And you may have heard about EPDs, what they are. That's an environmental product declaration. So people putting building products on the market, whether it's a concrete curb, in this case it's insulation, a beam, a steel beam, increasingly they're being required to prepare EPDs. So that's an independently verified statement of the environmental impact of that product. It includes carbon. It also includes other elements of environmental impact. And the more EPDs are prepared, the more clarity and transparency and accuracy we have in calculating footprints on projects. So that's something that all the building products industry is getting on board with at the moment. So moving to the level 1, then reducing the embodied carbon. A lot of the conventional methods are underway at the moment. There's a lot in this slide. It takes into account things like design efficiency. So let's say structural design. You may have used a certain spacing of beams, a certain slab depth. You may have built in a certain factor of safeties, and maybe there's a generosity there or a kind of a conservative approach. We have to go back and re-examine those. Definitely for people specifying structural steel, concrete slabs and so on, even a very, very small percentage change in the strength of your concrete, the depth of your slab, the spacing of your beams, even a 5 or 10% saving there can make a very big impact on your footprint. Same for people designing foundations and so on. So there's just lean design and efficiency, there's gains to be made. Then you have look at material selection, whether it's your concrete specification. Again, a lot of progress, we're moving away from a lot of the traditional mixes, moving towards lower carbon mixes with GGBS or PFA fillers and so on. also low carbon steel alternatives. So that's very much within our grasp and not a difficult and not a big change in philosophy for our designers. Internal finishes in buildings, internal kit out, again, there's maybe a leaner way to do things, or maybe materials that have a lower footprint that can be employed. Moving on to the construction processes, a lot of the big contractors are already in the game here. They're switching to electric plant, they're switching to hydro-treated vegetable oil instead of diesel. They're looking at, increasingly, there's a lot of emphasis on off-site construction and modern methods of construction, which, if they can gain time, reduce program, manufacturing in a controlled environment reduces waste, usually a bit more energy efficiency. So even by reducing the construction period itself, and if you can knock 5, 10, 15% off a construction period, that in itself is going to lead to energy savings. And also there's the use of digital design tools to optimize design, to reduce waste, reworking, and so on. So there's a lot to be gained through good use of digital technology. So all of that is well within our grasp, and typically companies are setting targets to get a 20 or 30% reduction in their embodied carbon just through these, let's say, conventional methods. Here's an example of a study that was done for the UK Green Building Council. They looked at a housing scheme for 750 houses in Cambridgeshire, and this was purely the civils and the structural, the piping, the drainage, the roads and footpaths. So they found that you could reduce the carbon footprint of that by changing the design and just being leaner and maybe more nature friendly, reducing the depth of paving, reducing the width of streets and so on. 20% reduction in the carbon footprint, and the cost increase there only 0.6%. So that's just a fresh approach to design, a fresh lens, and moving away from business as usual in that layout. So, and our own mothership, if anyone joining us from Cork, I think there are a few Cork people on the line, you may have passed by the Inishmore, the original MC O'Sullivan mothership, and that's been recently refurbished. So look, we had the option of demolishing it, changing it around. We kept the existing structure and just did an internal refurbishment. So that's keeping the embodied carbon that was in the frame of the building. In terms of the fit out, you can see there's no suspended ceilings or anything like that. So you've gone for this bare look, again, another carbon reduction there in embodied carbon. And just the efficiency of space planning is another way to look at an existing building. Can you do more with your existing footprint instead of building an extension? Can you free up floor space for other uses? That's another way to reduce embodied carbon. So a question I'll ask the audience, you can think yourselves, is does carbon reduction lead to cost reduction? Is it always one follows the other? I suppose the answer is it's yes and no. So if you're in that stage where you're reducing investment, where you're avoiding major project, where you're in that lean design, where you're using clever solutions, yes. So for example, the Gaia project, Wills Brothers and ourselves, they didn't just do that to save carbon, they also saved money on the project, it's a program. And there are an awful lot of occasions where your efficiency, your leanness and your reduction in material use is going to save money for the client. When you move down through and you move to other areas like the more demanding innovation, where we need new materials and maybe new techniques that are less familiar, where there's less economy of scale, in some cases the cost is increasing. And there's kind of a line there where it's a little bit more difficult for clients. Everyone's in favor of carbon reduction, but if that new concrete mix, it's going to save you 2,000 tons, but it's going to cost you 50,000 euro more on your contract. Is the client going to say yes or no? So that's we're kind of at that situation now where we're beginning to measure and we're beginning to realize there are some tricky decisions to be made. So I suppose for the going in point is to try and find reductions that are cost neutral or cost beneficial, but then to push the client and say, look, if you're serious about carbon reduction, this extra investment is worth it. So going to the level 2, reducing embodied carbon further, where will we get, say, the next 30% of reduction? It's really all going to be linked to innovation, particularly around low carbon materials. So novel materials and novel building systems. An element of that will be things like biogenic materials, such as wood or other organic materials. So they have a footprint, but it's much lower than synthetic materials. And the carbon that's in a piece of wood, like the paneling behind me, that was extracted from the atmosphere to develop in the first place. So it's generally regarded as, apart from the processing of the wood, the material itself can be taken as carbon neutral. So To get this extra 30%, we're going to have to be a lot more ambitious, and we need a lot more flexibility as well from people setting building standards and from clients approving completion and so on. So just to give you an example, say for the traditional materials, there are low carbon roadmaps being developed for concrete. So the ICE has just published one, and on the right, Highways England has just published one for concrete, steel and asphalt. And in the diagram there, you can see the range of opportunities there are, even working with a familiar material like concrete, just to look at how do we reduce the footprint. So yes, the cement producers have to look on lower carbon fuels and lower carbon production processes, and they are doing that, but it will take some time. But straight away, we can look at lower cement content. We can look at pile board formers. We can look at reduction in binding thickness. Explore how we transport materials, maybe low emission vehicles. Look at curing strengths. If we're using concretes with a mix that has a slower strength gain, that we allow for that we don't rule those out on the basis of a 28-day strength, when maybe a 58-day will be adequate. So there's a whole range of options being chosen. So I suppose the traditional materials, the steel, the asphalt and the concrete, they're all responding and rolling up their sleeves to take on that challenge, and the cement companies as well. I suppose there's another level we can go to then, where we go back and re-examine what we know as traditional acceptable design. So the case study here is the University of Bath, where they looked at the opportunity for a thin shell vaulted floor slab approach, and that the man is standing on the vaulted slab there. So their estimates on that is you can just see how thin that is compared to what we're familiar with. That research estimated that you could reduce the carbon footprint for an equivalent slab by 75% over the conventional. So that's going back to the university's cooperation then between industry, university researchers, material producers, and coming up with new approaches and being prepared to move away from the tried and trusted. And that's going to take a little bit of time and take investment, and the initial solutions will be a bit more expensive. Here's another one just from, there's an array of novel materials emerging that are trying to enter that low carbon materials market. So this is an interesting one. It's a reinforcement bar, not made of steel, but made from basalt. So it seems to be a crushing of basalt rock and reforming it into both a mesh, various forms of mesh and a reinforcement bar. So again, something we wouldn't have heard of, wouldn't have thought of. It's going to be in competition with steel and other traditional materials. So we have to prove it, we have to test it, and we have to have the courage to use it. And I suppose start small pilot schemes where there's maybe less risk, where the durability is an issue, and lots of laboratory testing required. Another avenue for sort of dramatic reduction in carbon will be using traditional or biogenic materials, so naturally occurring materials grown from timber or other plants. What you see in the picture there would be an example of a tall structure built without steel or concrete in the structure. So the wood here is taking on structural loading, and there's an increasing emphasis on this globally to try and push buildings up. Maybe familiar with timber frame buildings, 2 stories here, but these are pushing to 8, 10, 12 stories and taller buildings, achieving fire safety, achieving structural stability. But if you take out the steel frame or the concrete frame from a structure, you make a massive saving in the carbon footprint. So this is another avenue of development. At the moment in Ireland, the CLT isn't manufactured here, so it has to be imported, but there is research going on into how we can adapt the Irish timber to create our own CLT paneling systems and to compete and produce locally available CLT options for building here. And the good news on the innovation front is that there's a new National Centre for Innovation has just been launched just before Christmas, and it's centred or led by the University of Galway, but taking in University College Cork, Trinity College and UCD. The 2 co-directors will be familiar to members of Engineers Ireland, Jamie Goggins, who was a member of the not the executive, but the council for a number of years, and Magda Hadjukovic, who also has contributed to the Engineers Ireland Sustainability strategy and spoke at our annual conference this year. So we're in really safe hands with this. There's a real ambition there, there's a drive. This is going to bring together a lot of researchers from the various universities, so we'll have enhanced resources for testing, for modelling, and the whole emphasis here is on to try and drive collaboration between industry, whether that's concrete producers, steel producers, the users, so house builders, modular construction companies, and the academic world. So it's a very exciting venture, and it's sponsored by Enterprise Ireland with a lot of government backing. I suppose one thing I'd like to touch on, it's not the focus of tonight, but the relationship with the circular economy. So it's another theme that's strong on sustainability. And definitely if we can find solutions that increase resource efficiency and reduce waste, they're inherently going to reduce carbon. So this is a really good picture. We all played with Lego. We didn't scrap the building at the end and throw it in the bin, or we didn't take the little bricks and crush them down and recast them into new Lego bricks. We took them apart, we saved them, and we reused them again and again and again. And building design need to move into this to circular design systems. So whether it's a concrete slab or a steel beam or a column or a timber panel, can we capture that? And if that building reaches its end of life after 30 or 40 years, can we reimagine the use for that same component without having to recycle it in some energy intensive way? So there's a lot to be gained there. There's a whole other talk on the circular economy and carbon reduction. So just moving on then to the regulatory side of things, and what are the drivers that are pushing this forward? Certainly the European Green Deal has set a really important agenda. It's all about economic recovery, it's about employment creation, but in very much a low carbon society. And cutting emissions by 55% compared to 1990 levels is a really, really big target. So a lot of the legislation and policy that's trickling down is really driven by the Green Deal, both for carbon reduction and for circular economy. So our own climate mitigation approach, we have an all-of-government climate action plan, 2021 and now updated to 2023. That has set sectoral carbon budgets, multi-annual carbon budgets, and that's assigning a limit on the total emissions that we can emit into the atmosphere in that period. And at the moment, and through the latest climate action plan, that's now been translated down to sectoral budgets. So it's beginning to say not just our national targets, but our transport sector target, our industry sector target. And there's annual measurement and reporting. So it's beginning to kick in here that we're really beginning to realize the changes that are going to have to come, and they're going to have to come very quickly. And we've a legally binding piece of legislation, the Climate Action and Low Carbon Development Amendment Act. So that's enshrined in law the objective of reaching carbon neutrality by 2050 and of reducing greenhouse gas emissions by 51% by 2030. So really, really ambitious targets there. So ourselves, engineers individually and engineers as Engineers Ireland, this is a challenge that we've really got to respond to and quickly. So for example, the recently published Climate Action Plan, for the first time, it's set specific targets for embodied carbon reduction. So under the heading of industry, we want to decrease the embodied carbon in construction materials by 10% by 2025, and increasing that to 30% for materials produced and used in Ireland. So that's something we can control by 2030. So that's a tall order for all the construction product manufacturers, whether you're insulation, metal cladding, steel frames, concrete, precast, all of that will come under that target. There's also under the built environment an ambition there to, this is quite specific for public bodies. So public bodies spend a lot of money, develop a lot of infrastructure, and there's a requirement now for public sector projects to set specific targets for materials like low carbon cement products, and to address embodied carbon in the contract specification. So the project I showed you there in Kurdistan was maybe a pathfinder, but that's going to become the norm. So very quickly, these targets will translate down to the design teams, who'll pass them on to the construction teams, who'll pass them on to the material suppliers. So this is beginning to kick in now and have more teeth than it had up to now. In the UK, there's a lobby group that want to push for a new amendment to the building regulations, and they're calling it Part Z. So at the moment in Ireland, our Part L sets an NZEB standard, nearly zero energy building, but that's in the operational side. And to be fair, in Ireland, we've got very, very high operational energy requirements, but we don't have anything at the moment on embodied carbon. So in the UK, they're talking about setting mandatory limits to propel the industry into more comprehensive testing and certification, more effort at design stage, and a further focus on construction processes. And it's already happening in some other European countries. So the Scandinavians have taken the lead, and also Germany, Netherlands, and France. So what you have here in their building regulations, you have starting with the requirement to do your calculations and do your whole life assessment and to learn what embodied carbon is in the building. And usually switching over from about 2025 onwards, then they're setting actual targets and benchmark limits that have to be met. So in the same way as you have to design a building with a certain degree of air tightness, fire safety, in the future, we'll have to design a building with a certain level of embodied carbon. And that'll be benchmarked from the initial work over the first few years. So that's on the way here. It's not part of the climate action plan specifically yet, but I don't think it's too far away. Another approach, regulatory, and this is interesting in the London plan. So this is the development plan for London, and they've moved ahead of the UK national requirements. And they're now requiring, for major developments, they're requiring a whole life carbon assessment as a part of the planning approval stage. And they're also looking for a circular economy statement for the larger schemes. So I think it's an example of another regulatory tool, not the building regulations, but the planning code being used to set the standard and to push for embodied carbon reduction. So often London moves ahead and the UK follows. So it'll be interesting to see if this takes root in other jurisdictions as well. So I suppose if that's where things are moving regulatory and maybe in terms of the overall industry, if you're a specific organization or a specific designer, or you've got a responsibility for developing infrastructure or buildings, what can you do yourself? I suppose the steps would be what you can measure, you can manage. So start by getting a better understanding of what impacts your project are having. If you're appointing design teams, it's challenging them not to just copy and paste what they did the last time, but challenging them and the construction teams to reduce embodied carbon. And you're going into that in the knowledge that we don't really know an awful lot. But if you start with your baseline benchmarking and do your research on that, you get a feel for it. The third, once you've done that, is to move on then to look at your overall portfolio. So if you're a big organization like TII or OPW or Ironwood Airn or a big energy company, you can look across all your projects and start to combine the information that you have and get some more intelligence. Like, where is our footprint really? Is it in materials? Is it in transport? What type of buildings are biggest on our list of embodied carbon? But before you do all this, you maybe need to step back and ask yourself, does your organization have an ambition? Have you got a policy on what your attitude is to embodied carbon? Have you got a pathway to 2050? Otherwise, you'll get down to your step 2 and you'll find that, well, I can reduce embodied carbon, but it's going to cost more, or it's going to be a lot of difficulty. And you may just let it drop unless your organization has made a strong commitment and has signed up to taking those hard steps and pursuing targets diligently. So this is where having a really good blueprint, really good leadership, and a strong strategy at organizational level is important. When you get down to project level, there's a lot of good guidance in past 2080 about it's a whole team approach. So engaging designers, contractors, whoever the client for the project will be. But what's really important is that there's an overarching goal, that you decide at the outset what you want to achieve on the project, and that there's a governance, so that in the same way you have a governance system for health and safety in any big construction project, and you've got reporting and you've got clear lines of authority, we need to replicate this for carbon as well. So your governance can be what the requirements are, what the targets are, what the reporting requirements are, and who's responsible for what. Once you have that set up, then you can set your design targets for your design team. They will translate that down into actions, revised designs, and also construction stage targets. And all the time you're feeding this back up. And also then you're setting your operation stage targets for what kind of operational efficiency and maintenance efficiency you want. So it's worth thinking about, worth researching the past 2080, and before you initiate a project, try to get these good principles integrated, and it'll pay dividends in the long run. The good news about this is, if you follow this, you're going to have a good, clear understanding at the end of your project on what your footprint was, where you made your reductions, what the additional costs were, and so on. And then you can bring that back together. This is an example from Skanska of where they combined all their major construction projects from Northern Europe. I think this was the kind of Germany and Poland area, and very easy to stack together. So they're using the A, B, C, D categories that I showed you earlier. And they can see then across their portfolio, materials there is easily the highest. So all of 92,000 tons, I think, of their footprint was in materials, followed by energy, followed by machines, followed by transport. So they can straight away see that the materials is the area that they're going to pursue. And then on the right-hand side, the quarter by quarter, they can see which projects are contributing what carbon. And if they bring in policies like cost of carbon or some other accounting formula to help reduce this, they can see the benefit, they can see the impacts of that over time and how that kicks in. And if they change their policies, for example, on EPDs or types of concrete mix, they will be able to plot that and see what difference it's made, not just on one project, but across the portfolio. So this kind of business intelligence is the next stage then when we start having data to deal with from individual projects. So look, aiming for net zero is the next step. Can we take a project and really drive for a net zero overall project? Some companies have the ambition of a net zero asset, and we've developed, I suppose, an approach to that in RPS, how we go about doing that. So it's all about setting the strategy and designing the brief at the start, having a concept design that embraces the opportunity, really hard on life cycle assessment and whole life carbon assessment during the design stage, design and collaboration, then getting the contractor and the design team very close together. When you go to construction, making sure carbon is managed and reported. When the asset is handed over, all that good knowledge and all your baseline assumptions and your design assumptions need to be handed over as well, and that kind of training stage. And then monitoring and reporting performance and use is important. So there's a lot to take into account. Just on we're working on the Galway to Athlone cycleway project it's a Westmeath County Council are leading it on behalf of a number of local authorities, and TII are coordinating. So on that project, we're exploring the opportunity to make the entire cycleway a net zero carbon project. So there's two elements to that. The first element is driving down embodied carbon through design changes and innovation. And the second element is looking at the amount of carbon then in operation and embodied, and looking for opportunities for carbon sequestration within the project itself, whether that's through renewable energy generation, through carbon sequestration and tree planting, or it's through peatland regeneration. So that's going to be an interesting concept to see, can we achieve a fully net zero project? And if it can be done on a cycleway, then maybe it can be done on bigger schemes as well. So I hope it was worth you staying online. We still have 74 online, so thanks for your attention online and in the audience. Thanks very much.